So today we start from what do you mean by ohmic material and what do you mean by non-ohmic material. So see, ohmic material means from Ohm's law we know V is directly proportional to I. So if any material follow this rule, V is directly proportional to I, these are called the ohmic conductor or ohmic material. Similarly, in some example, like for silicon, if this one is current, this one is voltage, it's not straight line, it's like this, and it also look like this. So this one is in milliampere, this one is in microampere, voltage and current. So see, voltage and current are not straight line. If it is a curved line, then it is called non-ohmic material. Non-ohmic material. So if they ask you question, if examiner ask you question, what do you mean by ohmic material and what do you mean by non-ohmic material? So a material is ohmic if it satisfies voltage is directly proportional to current. But if it does not satisfy voltage is directly proportional to current, like it's not a straight line, it's a curve. So this type of material are called non-ohmic material. Example, semiconductor. After that, one more important part, which is very important in terms of board as well as for entrance exam, is we all know resistance is equals to rho L by A, where rho is the resistivity, L is the length, and A is the cross-sectional area. Now case one, in which if we cut a wire in n equal part, or if we add a wire in n equal part, means either its length decrease or its length increase, but not without stretching, means you just cut it. So when you cut a wire, suppose this one is a wire, if you cut it like this, so what happened, its material remains same. When you cut it, not iron become gold, so then everyone cut the wire and become this iron strip become gold strip. So that means when you cut the wire, its material remain as it is. So iron become iron, gold become gold, copper become copper. And when you cut it, its cross-sectional area remains same. So what we can say, case one, if we cut a wire or if we add a wire, resistance is directly proportional to length. This is the first part, a simple part. So what happened? Example, suppose they give you a question like this: R is a wire of resistance 10 ohm, its length is L, by cut it in 3 equal parts. So what is the length of each part? L by 3. Suppose we cut it in 3 equal parts, so length of each part is L by 3. Now the question is that find the resistance of each part. Question is that find the resistance of each part. So very simple, R2 by R1, let 2 is the new one, 1 is the old one. So what we can write, L2 by L1. So L2 new one is L by 3 and the old one is L. So what we have, 1 by 3. So new resistance R2 is 1 by 3 of the old one, that is 1 by 3 of 10, that is 10 by 3 ohm is the new resistance. That is the case 1. Now case 2, which is very important. Case 2 is very important. Suppose by stretching or compressing, if you change the wire, means by stretching let L become 3L, or by compressing L become L by 3. So if this type, if you change the wire, so what happened, as the length is increasing, cross-sectional area decreasing, and if the length is decreasing, cross-sectional area increasing. So basically what happened, by stretching or compressing, if L become, suppose NL, we treat in that way, ki n times it will be either increase or decrease. So let's start with increasing, see what happens, same thing follow. Length as well as cross section area both change. So length and area both change, but volume remain constant. Volume remain constant. So what happened? Volume, that is area into length. So we can say volume of the initial, 1 for the initial, 2 for the final. What we can say, area 1 length 1, that is area 2 length 2. So if we want to compare them, so what happened? A1 by A2, that is L2 by L1, we can write in that manner. Now what we know, if we write R2 by R1, that is resistance of the new one, and R1 means resistance of the old one. What we have, rho is the same material, length is L2, area is A2, rho is same, length is L1, area is A1. So rho cancel, L2 by L1, and this one is A1 by A2. Now we know A1 by A2 is, we can write L2 by L1. So we can write L2 by L1 into L2 by L1. So what we have, L2 by L1 square. What do you mean by that? That means R2 by R1, L2 by L1 square. From that we can say one thing. See, resistance is directly proportional to length, and here R2 by R1, L2 by L1 square. So from that we can came a conclusion that R is directly proportional to L square. So if the question asks you in that manner, if we change the length, increase or decrease by stretching, so then how the resistance change? It will depend on the length ka square. I give you one example, then you understand it. Suppose the question is that a wire of resistance R, suppose 10 ohm, length is L, by stretching, L become 3L. And the question is that find the new resistance. Find new resistance. So we know as it is the stretching process, that means resistance is directly proportional to length square. So what we can write, new resistance 2 by old resistance 1, new length 2 by old length 1 ka whole square. Now L become 3L, so that means it is 3 times increase of the initial one, and it's a square. So what you have, 9 times. So R2 is 9 times of R1. Now your R1 is how much? The old one is 10. Now your R1 is how much? Your old one is 10. So what you write? 9 into 10, that is 90 ohm. So your resistance is 90 ohm. Now see, examiner ask you in this type of question also, you know very basic of series and parallel. So let we know what do you mean by series resistance and what do you mean by parallel resistance. So they ask you question in that manner also. This is a single question. They can ask you one more question. A wire of resistance 10 ohm, length L, by stretching it, L become 3L, and then make it a square. And then after 3L, then make it a square, make it a circle, and find the equivalent resistance between the point A and B. So now see, your R become 90. First of all, by stretching you make it 3L. So resistance is 90. Now you make it circle. So what happened? And you have to find out the equivalent resistance between the A and B. That means the diametrically point. Now this 90, you can say the upper one is 45 ohm, the lower one is 45 ohm. And we all know for parallel circuit, resistance of AB, that is R1 plus R2. So here both are same, the 1 by 45 plus 1 by 45. So what you have 2 by 45. So R of AB is 45 by 2 ohm. So that one is your answer. Hope you understand what I want to say. So this one is this type of question they can ask you. So for this type of question, the basic concept is whenever you stretch it or compress it, remember one thing, R is directly proportional to L square. The third one, which is very, very important, case 3, which is very, very important. Case 3, which is very, very important. Case 3, which is very, very important. Case 3. Suppose the question is like that: by stretching or compressing, they say instead of change the length, if they say the cross-sectional area change, means if they say ki radius is increase or decrease or diameter is increase or decrease, then what happens? So suppose R is the radius and they say the radius is R by N. That means you are changing the radius of the wire. So as well as you change the radius of the wire, that means what happened? Cross-sectional area change as well as length change. So if the cross-sectional area decrease, that means radius decrease. That means cross-sectional area decrease. If the cross-sectional area decrease, length increase. So how they are related? Let's see. So we know again for changing the radius of the wire or diameter of the wire, length and cross-sectional area both change and volume is remain same. So volume 1 is equals to volume 2, length 1, cross-sectional area 1, length 2, cross-sectional area 2. So now length 1, if you mention it in terms of diameter, so we know pi area means pi r square, or in terms of diameter you can write a d by 2 square, that is pi d square by 4. So you can write area means pi d1 square by 4, L2 pi d2 square by 4. So this 4 cancel, this pi cancel. So basically what happened, instead of diameter, if you write radius also, instead of radius, if you write diameter, if you write radius, same thing happen. Instead of radius, if you write diameter, it will be remain same. So let's see what happened. L2 by L1, if we write L2 by L1, we can write diameter 1 by diameter 2 whole square. Hope you understand. We move it in that side. This one is in this one. So we have this one now. Now R2 by R1, if we write, what we can write? Rho is the same, L2 is same by A2, rho L1 A1. So what we can write, rho cancel, L2 by L1, A1 by A2. Now again A1, that means you can write pi D1 square by 4, pi D2 square by 4. Again this pi 4 cancel. So what you have, L2 by L1, you have D1 by D2 whole square. And from here, L2 by L1, that is D1 by D2. So if you write it, D1 by D2 whole square into D1 by D2 whole square. So basically what you have, D1 by D2 to the power 4. So now see, R2 by R1, D1 by D2, दो के लिए एक के लिए दो. What do you mean by that? That means it's inversely proportional. So what we can say, that means R is inversely proportional to diameter to the power 4 or inversely proportional to radius to the power 4 if they mention you by stretching or compressing its cross-sectional radius of the cross-sectional area or diameter of the cross-sectional area change. So if they mention you is in that manner, remember, if they mention you in that manner ki by compression or stretching or compressing, if the radius or diameter of the wire change, so then remember one thing, ki radius is inversely proportional to diameter to the power 4, radius is inversely proportional to diameter to the power 4, or radius is inversely proportional, resistance is inversely proportional to diameter to the power 4, or resistance is inversely proportional to radius to the power 4. And this question is this type of question is so important. Once or twice this type of question asked in IIT as well as in AIPMT. So you understand why these are very, very important. I just give you one example. Suppose a wire of resistance 10 ohm, by stretching, suppose its radius become r by 3. By stretching means the length is increasing, so its radius is decreasing, means the cross section area decreasing. So radius of the wire become r by 3. Find the new resistance. Find new resistance. So very simple. What we can write, r2 by r1. See here it is mentioned radius. So if they mention radius, then also if they mention diameter, then also, because 2 is cancelled out. So r2 by r1 is what we write. It's inversely proportional. So r1 by r2, just reverse. दो एक तो उल्टा हो जाएगा, एक by दो. So the reverse means inverse, and power is 4. So what we write, r by 3 power 4, that is 3 to the power 4. So 3 to the power 4 is how much? 81. So r2 is 81 times of the r1. So r1 is how much? 10. So the answer is 810 ohm. So this 10 ohm become 810 ohm if you, by stretching, if you change the radius or diameter of the cross section area. So this type of questions are very, very important. This type of questions are very, very important. I send you the color code carbon resistance. So what happened in this color code carbon resistance? If we have a carbon resistance like this, if we have a carbon resistance like this, and in this carbon resistance, what happened? You have 4 color, 1, 2, 3, 4 color band. If you give me 1 minute, I think you see the 4 color.
Yes, sir.
4 color you see now. So many resistance you have. See, you see it, everyone?
Yes, sir.
Yes, sir.
So these are the color code resistance, like this one. See. So you have same like this 4 band you have, and we read it from kono color hi likhini ekhon dara na. You have 4 band, 1, 2, 3, 4, and we read it from left to right. First 2 are the digit. So digit 1, digit 2. First 2 are the digit. Third color represent you the multiplier. And the fourth color represent you the tolerance. TOLERANCE. So in this way, we have a 4 color, digit 1, digit 2, first 2 color code. These are the code. First 2 color code represent the digit. Third one represent the multiplier, and the fourth one represent the tolerance. Now this one is the color, and this one is the digit. So we start from 0. So what we write, for black we write 0, for brown we write 1, for red we can write 2. These are the color. For orange we write 3, for yellow we write 4, for green we write 5, for blue we write 6, for violet we write 7, for gray we write 8, for white we write 9. Now gold, silver, no color. So digit is up to 0 to 9. Don't think in that way. So you have 0 to 10, 9. You have this 9 digit. After that, what we can write? We write multiplier. So multiplier 0, that is 10 to the power 0, which is 1. You can write 10 to the power 1, which is 10, 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power 6, 10 to the power 7, 10 to the power 8, 10 to the power 9. After that, you can write for gold, you can write 10 to the power -1, for silver 10 to the power -2, for no color 10 to the power -3. Although mostly they don't give you that part, but still if they give you. Now after digit you have multiplier, now you have tolerance. Tolerance is especially you have for gold, that is 5% tolerance. For silver you have 10% tolerance, and no color you have 20% tolerance. And how you remember all this color? So the formula is B.B. Roy, Great Britain, very good wife. Gold, silver, तो समझ में आता है, gold, silver, no color. So mainly up to this you can remember, up to this white, you can remember by B.B. R.O.Y. Roy, B for black, B for brown, R for red, O for orange, Y for yellow. B.B. Roy, great, great for green, Great Britain, Britain for blue, Great Britain, very violet, good gray, wife. So you can remember it in that way. B.B. Roy, Great Britain, very good wife. So you get it. Now see what happened, how they given you the question. They given you question, a color code, carbon resistance. The colors are given like red, comma, yellow, then orange and silver. And read it from left to right, find the resistance of the color code. So it's a very simple. R is equals to first two, red and yellow. First two are the digit. So first digit is red. Red is how much? Tell me how much? Bolo, bolo.
So
Red
2.
is how much?
2.
Yellow is how much?
4.
4 into. Orange is how much?
10 to the power 3. 3.
10 to the power 3. So into, और देखो multiplier का मतलब है गुणांक, मतलब you have to multiply how much? 10 to the power जितना है 3, and then plus and minus. You know from error analysis class 11. अरे यार कौन है रे भाई? देवजीत बंद कर. Plus minus silver. Silver is how much? 10% tolerance.
10%.
So you can write 10%. 10%. So this is the answer. Okay, this one is plus minus 10% ohm. Ohm, why? Because it's a color code resistance. So they can ask you this type of question. Sometime they ask you in this way also. Ki 35 into 10 to the power 4 plus minus 5%. Mention the color used in the color code. So देखो, the first digit is 3. So what you write, the first color is orange, right? First color is orange. Second color is 5. 5 is green. Third color is 10 to the power 4, yellow. And the last one is gold, माने GOLD, माने 5%. कभी-कभी वो ऐसा कर सकता है कि वो 2 के 3 के 4 के जगह पे वो 3 कलर देगा. कभी-कभी वो ऐसा कर सकता है कि वो 3-4 के जगह पे 3 कलर देगा. सो चौथा कलर क्या है? नहीं है. नहीं है का मतलब क्या है इंग्लिश में? नो कलर. सो नो कलर मीन्स हाउ मच टॉलरेंस? 20%. So then you can write 24 into 10 to the power 3 plus minus 10%. Sorry, 20%. Hope you understand. कभी कभी वो ऐसा भी देता है, इसको भी हटा देता है. So how many color you have? 2. तो अगर वो 2 कलर दिया, ये हालांकि इट्स रेयर केस कि वो कितना कलर दिया, 2 कलर दिया. अगर वो 2 कलर दे, इसका मतलब 2 बार नो कलर है. So that means your resistance is 24 into no color means how much? 10 to the power minus 3 plus minus 20%. Hope you understand what I want to say or what I mean or what do I mean. मैंने जो बोला आप लोगों को क्या? So next topic is arrangement of resistance. So obviously the first one is series arrangement. So what happens, suppose we have 3 resistance R1, R2, R3, which we connected with a battery of voltage V. Let this one is plus, let this one is minus, and I is the current supplied by the battery and the same current received by the battery. So this one is almost same like the last chapter, capacitor, where the Q amount of charge supplied by the battery and Q amount of charge received by the battery. Instead of charge, here we can write current. So current is moving in same way because in series arrangement, same amount of current flows through all resistance and individual voltage is V1, is V2, is V3. So what we can say in series arrangement, total voltage is the sum of the individual. So we can say V1 plus V2 plus V3 is the total voltage. Now as the let R is the equivalent resistance, that means instead of this 3, if we use one resistance, capital R, we get the same value. So what we can write? We can write current into resistance, that is current into resistance 1, current into resistance 2, current into resistance 3. So R is equals to R1, R2, R3 for n number of resistance. We can write RS stands for series, that is R1, R2, ... Rn. Now we can write one more thing. If R1 is equals to R2 is equals to Rn is R, means all are the same value. So we can write R plus R up to n times. So what we write? Nr. So that means we can write directly. Suppose we have 3 resistance of 10 ohm each. So total resistance is 3 into 10. We can write directly. Okay. Achha. So hope you understand this part. So this is the recording now. So this is the series arrangement. Now if I say parallel arrangement, so what happened in parallel arrangement? Parallel arrangement, suppose these are the parallel arrangement. So 3 resistances there. Let it be R1, let it be R2, let it be R3, and we connected it with a battery like this, voltage V. So I is the current supplied by the battery and I is the current received by the battery. Now this current is divided in 3 parts. Let it be I1, let it be I2, let it be I3, and these points are called node. That means the voltages remain same. For all of them, the voltage is same. So what is the basic difference between series and parallel? In series, same current flow, different voltage. And in parallel, current is distributed and the voltage is same. Now in series, if one is broke down or one circuit is, if you remove one circuit, so the whole thing is no current is able to supply. But here, if you just remove one circuit, the current will flow from the other. Okay. So now here, as the current is distributed, so what we can say, I is equals to I1, I2, I3. Now again, if R is the equivalent resistance, again R is the, if R is the equivalent resistance, so what we can say, V equals to IR, so I equals to V by R, that is V by R1, V by R2, V by R3. So 1 by R is 1 by R1, 1 by R2, 1 by R3. For 1 by R parallel, that is 1 by R1 for n number of resistance. 1 by R2 dot 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 1 by Rn. If R1 equals to R2 dot 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 equals to Rn equals to R, so 1 by Rp is 1 by R dot 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 up to n. So what we have, n by R, so Rp is R by n. So this one is my parallel arrangement. Now we can try some numerical on the basis of this series and parallel. And today, obviously, we start with a very basic some numerical, and one more important, or you can say a plus point, that you already complete capacitor. So as you complete capacitor, the process is exactly same. The rule regulation is exactly same. Just imagine in place of capacitor, you just imagine the resistance. The rest is exactly same. So let's start with a simple resistance question. Suppose we have this type of resistance. This point is suppose A and this point is B. Resistance is R, 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 R. What we have to find out? We have to find out the equivalent resistance between A and B. So before you start, one thing you have to remember, that these are the plain wire, these are the plain wire, these are the plain wire, these are the plain wire. That means you can say these all plain wire are a single point. You all can imagine them as a single point. Means why? That means, what do you mean by that? Suppose these are the plain, this is a plain wire. This is the plain wire. If this is one resistance, suppose this is one resistance, this is one resistance, and this is one resistance, R1, R2, R3, R4, and they are connected by the plain wire. So in this type of situation, what I want to say, you can write in that way also. 1 point, 2 point, 3 point, 4 point, they are the single point. That means if you write in that way also, they are the same thing. So this one and this one, same thing. If you understand now what I want to say. You connected in different point, and here you connected in same point. As in between them you have a plain wire, so you can say they are the same point. So in plain wire you can do this one. So similarly here now see, if you think in that way, so then what happened? This is your 1 point A, one resistance is there R, next point is this, next point is this, next point is this, next point is this. Between these 2 points you have 2 resistance, so you can write in that manner also. R and R same thing na, ये ऐसे है ये ऐसे है, same ही तो मतलब हुआ. Next you have 3 resistance, 1 2 3. Next you have 2 resistance, next you have 1 resistance. So basically you have A, R, now you have 2 resistance, so R by 2. Now you have 3 resistance, R by 3. Now you again have 2 resistance, R by 2, R, and this point is B. So now these are all are in series. So in series what happened? In series you just add them. So R plus R by 2, R by 3, R by 2 plus R. So 6 is the LCM. If you take 6 as a LCM, so 6R plus 3R plus 2R plus 3R plus 6R. So what you have? 6 6 12 18 20 by 6. 20 by 6R, that is 10 by 3. R is the resistance. Hope you understand. We want to stop that questions and all. You can do in between. You can do one more thing. तुम लोग देखोगे, तुम लोगों को मैंने जो कैपेसिटर्स में जो सर्किट्स दिया था, you can try the same circuit. Just in place of C, you can write R. Then you can try the same question. These are also the same question we solve in capacitor. Okay, so you can try it in that resistance also. उसके बाद तो हम लोग questions देंगे. So today I end my lecture here. That is my second lecture.